Welcome to another session in our series of tutorial for R for data science, and in this session we are going to tackle data structures. And data structures are objects which we manipulate in our day-to-day basis in R. So it's very important for you to understand what are data structures and how you manipulate data structures. For example, R is a vectorized language, so it's good that you understand what vectors are. It's also good you understand what matrices are. It's also good you understand what lists are. So let's start with vectors. Vector, it is the easiest way to store multiple data types of the same type. So vector stores, or it allows you to combine data types of the same. For example, you want to store maybe marks of certain students, so you will use vector, and vectors are created by the C command, or C, the C function, concatenate, the repeat or replicate, and the sequence function. So here I'm creating an object called vector1, and in this vector1 I'm assigning it true, false, false, true, false, false, and true. So this is a logical vector. Let's run that, and you can see our environment here is empty. If we run, vector1 pops up here. So if you want to see what vector1 is, you run vector1, and here it is true, false, false, true. So in some operating systems and in some computers, these logical data types or logical vectors, you can use capital T and capital F. So you use capital T for true and capital F for false. Then I'm creating a second object called vector2, and this vector2 is a character or a string vector. I run it, there it is. It has popped up here. That's vector2. I'm creating a vector called vector3 here, and I'm assigning, and I'm using the replicate function or the repeat function. So what am I saying here? I'm telling R, can you repeat 10 6 times? So repeat the value 10 6 times. And if you want to know much about the repeat function, you write question mark and then repeat, then you run, and it has popped up here in our help. So it's a base function, so it's from the base package. It replicates element of a vectors and a list. I'm creating another vector here called vector4, and I'm still using the same function repeat. I'm telling repeat 1 2 3 2 times. And there it is. Vector4 is created, so it's 1 2 3 1 2 3. Then I'm creating vector5. Vector5 I'm using sequence, so you can as well know much more about the sequence by typing a question mark sequence, and it will pop up here. Let's run that and see. And here it is. It generates regular sequence. So I'm creating a vector5. I'm telling R, generate a sequence from 1 up to 6 and increment or increase it by 1. So it will be 1, then it increases by 1, it becomes 2, it increases it by 1 again to become 3 until we reach 6. So vector5 sequence 1 to 6. Run that. It is vector5. So if I want to see vector5 how it looks like, I run vector5. There it is, 1 2 3 4 5 6. So that's basically how you create vectors. That's you use sequence, you use C, and you use repeat. So R is a vectorized language, and most of our computations will focus, or most of our analysis will be based, or will focus on vectors. So I can as well extract values within a vector. For example, let's see, vector1 is a logical vector. What if I want this first value? of vector 1. So I'll use what's called the square brackets or the subsetting brackets. I'll type vector 1, then subsetting brackets, so vector underscore 1, then I use subsetting brackets here, and I put in the value which I want. So if I want the first value, I'll put there 1, then I run. What if I want maybe the second or the third value? I'll type vector underscore 1. If I wanted the third value, I'll put third, or if I want the sixth value, I use 6, then I run. There it is. It gives me the value true. I can also use in between. So if I want the value from the third to the fifth, so I'll type vector underscore 1 from the third value to the fifth value, and it's false, true, for false, true, and false. What if I want all values in vector 2? So this vector underscore 2. What if I want the third value? I want all the elements in vector number 2 except the third variable. This is where I'll use negative selection. So I don't want the third value from behind, so I'll type vector 2, then I include a negative 3. So it gives me 1, 2. Then the third value here, which is supposed to be 3, is not printed here. So basically, those are some of the operation in vectors. Let's continue with some operation of the vectors. We can also multiply vectors. For example, I'm multiplying vector number 4 by 2. I can as well add vectors like vector number 6. I'm creating a new vector called vector 6, and it's an addition of vector 3. Let's see that. Here it is, 20, 20, 20, 20. So it's the addition of vector underscore 3. I can as well divide this vector 20, 20, 20, 20 divided by 2, so it will be 10, 10, 10, 10. There it is, 10, 10, 10, 10. So basically those are vectors and some of the operations that are available or that we can perform on vectors. The second data type that we focus in is a matrix. So matrix is a two-dimensional array. It's arranged in a rectangular format. So it's a two-dimension whereby we have rows and columns. So it's actually you can think a vector can be thought of a vector in 2 dimensions. Actually, it's a vector in 2 dimensions. It can contain same or different data type in each column. So the matrices are in columns and in rows. Our matrices are created by the function matrix, and dot is seated to use the help command question mark matrix question mark and matrix question mark matrix, and it will give you everything you need to know about matrices. Here it is. It will give you even the use matrix. Then data is the data that you want to create that matrix. Then the number of rows that you want to create this matrix of yours. How many rows should it have? How many columns should it have? Then here by row is equals to false. Then what are the dimension names or the names of that matrix, or the column names of that matrix? So here let's create a matrix underscore 1, our first matrix, and I'm using the function matrix. So I want a matrix of values from 1 up to 20. Then the number of columns should be 4. So if I specify the number of columns to be 4, even if I delete this, R will automatically know that the number of columns should be 5. Then by row is equals to false. By row is equals to false. So R will arrange this 1 to 20 row wise. It will arrange it row wise. It will not arrange it by column. So the default is by row is equals to 4. I can as well delete this, and I can as well delete this, and R will automatically know that the matrix that I want to create should have 4 columns. Then it will automatically detect the number of rows. And then the default of by row is false. Let's run this and see matrix 1. Run matrix 1 as pop up. I can click on this, and here it is, matrix 1. So matrix 1, so you can see, as you can see, by row is equals to false. So it has arranged this by column, because by row is equals to false. So this 1, 2, 3, 4, 5, 6, 7. So that's what we mean by row. If we could have used by row is equals to 2, it could have arranged 1, 2, 3, 4. So that is matrix 1. I can as well create the second matrix, is matrix 2, and it's from 1 to 20, and then the number of columns is 4. So the number of rows should be automatically 5. But here I've said by row is equals to true. Let's run and see. And here is a matrix 2. If I click on this matrix 2 here, and here it is, as you can see, 1, 2, 3, 4. Here I've said by row is equals to true. So it has arranged the matrices in row wise. That is row wise. I can use this function called call names to add column names to a matrix. And this is what this function says. It says that insert column names in this matrix called matrix underscore 1, and the column names are 1, 2, 3, and 4. So I'm using the function column names to add column names to this matrix called matrix 1. So I'm telling R, into this matrix called matrix underscore 1, add column names, and these are the column names. So I'm assigning using this assignment function. If I run that, and as you can see, here is our matrix 1. So 1, 2, 3, 4. That is how you add column names to our matrix. Basically, the same way that I've added column names, I can use the row names function. So I'm telling R, into this matrix called matrix underscore 1, add row names, and these are the row names A, B, C, D. Let's run this. Now let's see how our matrix looks like. And here it is, A, B, C, D, E. These are the row names, and these are the columns. So basically, that's how you add column names and row names on matrices. Let's see operation on matrices. So this basically we are subsetting a matrix, and this is the syntax of how you subset a matrix. You write the matrix name. The first thing is you write the matrix name. Then immediately the first value that you put in there is the row name. Oh, actually, the row number, not row name, row number. Then this one is also the column number. So you subset by the row number and the column number. So the first argument is the row number, and the second is the column number. For example, if in our matrix 1, let's run matrix 1 and see. Here is a matrix 1. What if I want this value, the first value in the first row and the first column? So I'll write the name of that matrix, and then the subsetting brackets or the square brackets, then 1, 1. The first one is for the row number, and then the second value of the second one is the column number. Let's run this. So matrix 1, matrix underscore 1, the first row and the first column. So I want the value in the first row and the first column. I run that, and then it is given me 1. So if I want the value in the second row and the fourth column, so I'll write matrix, or I'll type matrix underscore 1, second row, the second row number and the fourth column number. I run that. The value in the second row, this is the second row, the fourth column should be 17, and that, and there it is, value is 17. If I want the entire row, I write the name of that matrix, and then the subsetting brackets or the square brackets, and then the row number, then comma. So here it is, if I want the first row, I'll type matrix underscore 1, and then 1, comma. And that is when it gives me the first row, the entire first row. If I want the entire column, should be comma first, then the column number. So if I want the first column, I'll type matrix underscore 1 comma 1, and that will give me the first column. I can as well multiply. For example, if I want to multiply the value of the first row, the value in the first row. If, for example, here I want to multiply the first column or the first row of a certain matrix and a column of another matrix. For example, here I want to multiply the entire row of the first matrix and the entire row of the second matrix. So I'll type matrix underscore 1, then comma for entire row, and then matrix underscore 2, the second 1 comma for the entire row still. And here it is 1, 12, 33, and 64. I can as well change a value that is inside a matrix. For example, the first value in matrix underscore 1, which was 1, I want to change this value to 100. So I'll define this position, which is the name of that matrix, then the subsetting brackets or the square brackets, then 1 comma 1. Then I use the assignment this assignment operator here, and then I'm telling R the value in the first column and the first row changed to 100. Let's done that, and here it is. It has been changed to 100. I can as well change multiple values. For example, I want to change the entire second row into 100 to 103. So matrix underscore 1, the second row, I'm saying repeat the value 100 to 103, and I run that, and here it is that we change to 100, 101, 102, and 103. I want to let's perform some basic arithmetic operation on matrices. So it's only possible for you to add matrices of the same dimension. I'm creating an object called matrix underscore 3 here, and this matrix is from 1 to 9. Then the number of columns is 3. Let's run that. Then I'm creating another matrix called matrix underscore 4, and this matrix, I'm using the matrix function from 1 to 12. The number of columns is 4. Run that. Then I'm creating another matrix called matrix 5. Now I want to add a matrix 1 and matrix 2, and matrix 1 and matrix 2 have the same number of dimension. You can use the function dim dimension to check the dimension of matrix. What is the dimension of matrix 1? Dimension of matrix 1, let's run that. It has 5 rows and 4 columns. What is the dimension of matrix 2? The dimension of matrix underscore 2, dimension of matrix underscore 2 should be the same. It's 5, 4. So it's only possible for one to add matrix of the same dimension. For example, here matrix 1 and matrix 2 have the same dimension. Here they are. I can add them together, and here it is. I've added them, the matrices. Then let's try and add a matrix which are not of the same dimension. For example, matrix 3 and matrix underscore 4 are not of the same dimension. Let's add and see. And here it is. Error in matrix 3 and matrix 4. None conformable arrays. They do not conform. They are not of the same dimensions. Let's multiply matrices. Multiplication of matrices, we can multiply matrices element wise. We can multiply matrices element wise, or we can perform the normal matrix multiplication of matrices. So let's multiply matrix 3 and matrix 4. Let's see first how matrix 3 looks like. it is matrix number 3, then matrix underscore 5. Let's see that it is there of the same element. Let's multiply now using the multiplication, and in R we use the asterisk or the star, the asterisk to multiply. That's used for multiplication. So I will multiply matrix 3 and matrix 5, and this is the element wise multiplication. This is the element wise multiplication. Let's run that and see that, and here it is. So this is what R has done, element wise multiplication. It has taken this 1 multiplied by this 2, it gives me this 2, then 2 multiplied by this 3, it gives me 6. I continue that way until 9 multiplied by this 10, it is 90. That is the element wise multiplication. So it has selected element in the same position, it has multiplied with that element. But that's not how we multiply matrices normally. This is how we multiply matrices. We use this sign called percentage, asterisk percentage. So if you want to multiply matrices, you use percentage, asterisk percentage. That's how you multiply matrices. So here I'm telling R, multiply matrix number 3 and matrix number 4. So how you multiply matrices is you take the rows in this argument, then you multiply by the column in this argument. So the number of rows and the number of columns, the number of rows in matrix 1 must be the same to the number of rows in matrix number 2. Let's multiply matrix 3 and matrix 5. And here it is. For example, this 42. How did we get that 42? Let's first of all run matrix 3. Let's run matrix 5. Then let's run this multiplication. There, come here to our console. Here it is. So it has taken this multiplied by this plus this multiplied by this plus this multiplied by this. So here it is 2 plus 12 plus 28. It has given me this 42. So that's how you multiply matrices, row by column. You can find the transpose of a matrix. For example, matrix 1, transpose changes the rows into columns. For example, in matrix 1, if we perform the transpose of this matrix, these row names will become the column name. For example, transpose, you use the function T, then the name of that matrix you want to transpose. It is the column names, the column names were the row names, and the column names have become the row names. You can also perform the column sums and the row sums of a matrix using the function call sums. So call sums perform the column sum of column sums of matrix 1. And here it is the column sums of matrix 1, matrix 2, matrix 3. You can perform the row names the same. Let's look at the data frames. So data frames are two-dimensional array. So it's a table with the rows and columns. So rows are observations and columns are variables. So each column must have the same data type. So it's an advancement of matrices. So data frames are created by the function data.frame. For example, here I'm creating a data frame called data1, and this data frame 1, it is comprised of the vector 2, vector 1, vector 3, vector 4, and vector 5. Let's run that and see. And here it is, data 1. Click on this and see that, and here it is. So it has vector 1, vector 2, vector 3, vector 4, and vector 5. So you can use class to check the class of data. So you type class, then the name of the data frame. It tells me it's a data.frame. You can also use the structure to check the structure of that data frame. So it has given me that vector 2 is a character, vector 1 is a logical, vector 3 is a number, vector underscore 4 is an integer, vector underscore 5 is a number. So how can you subset, or how can you remove or what you want from that data frame? So we can subset data frames in two ways. You can subset it using the the matrix like format using the row and the column number, or you can subset them using the column names. For example, here I'm saying data underscore 1. I want the 6th row and the 1st column in our data table, our data underscore 1, and here it is 6. Then if I want an entire column, so I'll type the name of that data. In our case here, it's our data underscore 1, then the second column, comma, then the second column. If I want the entire row, data underscore 1, and then 2, then comma. I can as well subset using the column name. So the column names of our data frames are the vector names, for example, vector 2, vector 3, vector 4, and vector 5. So what if I want the 4th vector? So I can type the name of the data frame and then $sign, then vector underscore 4. I type that, it has given me all the elements in column in our column called vector underscore 4, and here it is 1, 2, 3, 4. So $signs, the function, this $sign enables you to extract a column name from a data table or data frame. I can as well use data, then comma, then 4. This gives me matrix like subsetting, and it will give me the same value here, and here it is. Now there are some conditional selection here. There is this equals to, greater than, this is equals to or greater than, less than or equal to, this is or, this is and, this is not equal to, and this is the $sign. So for example, you may want to select certain variable or certain columns in a data frame. For example, here in our case here, what if I want from the vector 4 column, I want whereby vector 4 is equal to 2. So I'll type data underscore 1, then data underscore 1, and then $sign vector underscore 4 is equals to 4. Now here I'm using double equal signs because I'm asking a question. I'm asking R. I want R to give me from this data table or data frame, this data underscore 1. I want it from the column number or from the column name vector 4 to give me where vector 4 has the value equals to 2. So that's why I'm saying data underscore 1, then this square brackets, then data, then $sign. So these $signs allow me to access this column called vector underscore 4, and I want where vector underscore 4 is equals to 2, and that, and here it is. It has given me where and vector underscore 4 is 2, and here it has given me 2 rows. What if I want to use greater than? So I want data whereby vector 5, this vector 5 is greater than 3. So I'll use data underscore 1, then subsetting brackets, then data underscore 1, and then I use the $sign that allows me to access this fifth this vector underscore 5 column. Then this comma here tells me I want all the rows. If I run this, I'm using here greater than. Let's run this and see, and here it is. Then giving me a vector underscore 5 is greater than 3, so 4, 5, 6. If I want to use less than, I change here and use the less than, then use comma, run that. Less than or greater than, I want whereby this vector underscore 5 is greater than 4. Run this, and here it is greater. It's greater or equal to 4. That means this 4 is less or equals to, no, this is what it's greater or equal to 4, that means 4 is inclusive. When I run this one, I want whereby is less than or equal to 3, less or equal to 3, that means 3 is also inclusive. 3 is inclusive. So I want to use here, I want to use not equal to. So I'm telling our data underscore 1 and vector 1 is not equal to 3. So I want it to give me where this one is equals to false. And here it is, does give me false. I can change this one. I can as well change this one. Let's copy this, bring it here. I can as well do this like this, remove this equals to, then I run. I change this one to false.